dear students. Welcome back to the online chemistry classes. In the previous lecture, we had started with the chapter Haloalkanes and Haloarenes. We studied the nomenclature and then we started with the methods of preparation. In the previous lecture, we had prepared haloalkenes from alkanes, that is by substitution of alkanes. Then we started off the method of preparation with alcohols. Yesterday, we prepared haloalkenes by the chlorination of alcohols. And today, we will continue with the preparation of haloalkenes. Yesterday, we had done primary alcohols, secondary alcohols and tertiary alcohols with HCl. We saw that primary and secondary alcohol require a catalyst anhydrous ZnCl2 to catalyze the reaction. But the tertiary alcohols do not require any kind of catalyst for the reaction. Today we will prepare bromoalkanes. The reactants would be the same, that is, we will be taking the substrate as alcohol itself. So when we talk about bromes, we have alcohol ROH. We will add NaBr along with H2SO4. This is the generalized form of the reaction. The products which we get is RBr, this is our haloalkane, plus we will get NaHSO4 along with water molecule. This is a generalized equation. You can use any alkyl group here. So let's just have a simple example. We write C2H5OH. This is ethyl alcohol plus NaBr plus H2SO4. We will get C2H5Br, that is ethyl bromide, plus sodium bisulfate NaHSO4 plus H2O, that is the water molecule. Now, apart from this, we can also use one more simple method for preparing bromoalkanes, and in that method, we will use red phosphorus, the halogen which we wish to add. Okay, so it can be written as generalized form Br2, or we can write X2. Here X2 can be Br, here X can be Br or I. So after this reaction we get RX. To specify, we have alcohol, that is ROH. We use red phosphorus and we use Br2. So we will get RBr. For the same, if I use red phosphorus along with I2, I will get Ri. So these are, the first one is alcohol when reacted with sodium bromide in the presence of sulfuric acids give us RBr, that is the bromoalkane. In the second one we use the alcohol molecule along with red phosphorus and the halogen which we wish to incorporate. In the first example we used bromine, so bromoalkane. In the second one we used iodine, so we formed an iodoalkane. So these are also preparation or direct halogenations. Now we will use the same substrate, that is the alcohols, but now we will not do the direct halogenation, like we will not that is phosphorus pentachloride, it will give us methyl chloride along with POCl3 and HCl. So this is an example of the action of phosphorus pentachloride on alcohol. Same can be done with PCl3. When we react PCl3, the products which we will get are RCl along with H3PO3. So when alcohol is reacted with phosphorus trichloride, we will have the haloalkane along with H3PO3. So now let's have an example. Ethyl alcohol when reacted with phosphorus trichloride gives us ethyl chloride along with H3PO3. So these are the two reactions where we have used phosphorus halides. Phosphorus halides reacting with alcohols to form the haloalkanes RCl and RCl. The next method of preparation is with alkenes. Now we will prepare our haloalkenes from alkenes. So now we will be using the double bonded species of carbon, that is the double bonded hydrocarbons will now be used, and now we will prepare from that. So the next is from alkenes. Alkenes are the double bonded species which we have of the carbon and hydrogen. Last year, that is in class 11, you all must have studied two rules. One is Markovnikov rule and the second is anti-Markovnikov rule or the peroxide effect or the Kharash effect. These two rules are used for the preparation of haloalkenes from the alkenes, that is the double bonded species. We have seen one thing, that if this is the unsymmetrical alkene and we add HBr, according to Markovnikov rule, we know that the addition molecule, or it is also known as the addendum, the negative part of this addendum will add on the carbon of the double bond which has less number of hydrogen atoms. So this double bond will break one free valencies and this will be Br and here it will be H. So this is addition according to the Markovnikov's rule. Now if we go by the peroxide effect or the anti-Markovnikov rule, same reaction will be taking place, but there will be a peroxide which will be used as a catalyst. So the products would be different. Now if I write the same equation, CH3, CH double bond, CH2, that is propene plus HBr. Now as the anti-Markovnikov rule or the peroxide, that is when the same reaction takes place in the presence of a peroxide, now the negative part of this addition molecule or the addendum will add on that carbon of the double bond which has more number of hydrogen atoms. So if I see these two carbons, here it is only one hydrogen and here two Br. So again we are there with a bromoalkene. This is the anti-Markovnikov rule, according to which the same addition has taken place, but the rule has been reversed. That is, the negative part has added to that carbon of the double bond which has more number of hydrogen atoms. And in the first one, that is in the Markovnikov rule, the negative part is getting attached to that carbon which has less number of carbon atoms. The next would be the reaction with the silver salts of carboxylic acids. The next one is the preparation of haloalkanes from the silver salts of carboxylic acids, and it is given the name after a scientist, so it is a name reaction, and it is Dicker reaction. Here we use silver salt of carboxylic acid. We use Br2, the reagents are CCl4, and we use a reflux in this. We will get the bromoalkanes in this reaction. That is, we will get RBr in this reaction. We will have RBr. That is, there will be a formation of bromoalkane in this reaction.
Right.
Along with this RBr, we will have CO2 also, and apart from that we will have AgBr. So now the silver salt of carboxylic acid, that is C2H5 COOAg, or we can go for CH3COOAg. This one you have already studied in your class 10, that is acetic acid. So acetic acid is CH3COOH. Now if I talk about the salt of silver, this H would be replaced by another cationic species, that is Ag. So this is the silver salt of carboxylic acid, or is the silver salt of acetic acid. We reacted with Br2, same, the catalyst would be the same, and the product would be CH3Br, CH3, this Br would attach over this. So this is the breakdown of this molecule, that is CH3COOAg will break. How? This would be the first part, CH3. This would be the second part, CO2, and one part is this, that is silver. We have two bromines here, that is we have Br and Br. Same, the bond will break. This Br will get attached over here, and one Br would get attached over here, and this CO2. So you can see in the product we have CH3Br plus we have CO2 plus we have AgBr. So the Hunts-Dicker reaction says that when the silver salt of carboxylic acids are reacted with bromine, they use carbon tetrachloride and they reflux it, we obtain the bromoalkene along with carbon dioxide and AgBr. In the next chapter, we will start off with the properties, or in the next class, we will start with the physical and chemical properties of these haloalkenes. First, we will finish off these haloalkenes, then we will